I'm Ethan Llewellyn, and today we're talking gas detection, lower explosive limit, and toxicity levels. Hello, and welcome to today's training video. I'm Lieutenant Ethan Llewellyn with the Liquefied Gas Carrier National Center of Expertise, and today we're going to begin our discussion into the gas detection requirements on a liquefied gas carrier and their associated components. The gas detection system on board a liquefied gas carrier is such a critical system and comprises so many pieces of equipment that we decided it was best to create multiple condensed training videos to cover the entire gas detection system requirements and how to properly test and calibrate the system to ensure it's in conformity to the IGC code. Today's lesson is part one of this series of gas detection videos, and for this lesson we're going to discuss the difference between lower flammable limits, percent by volume, as well as show how it's important to know the toxicity levels and flammable levels of gases being carried. This is imperative so crew members can ensure their gas detection is reading the appropriate dangerous vapor concentration, and Coast Guard examiners can understand what they need to be witnessing when carrying out gas detection calibration and testing. Additional gas detection information can be found in the Coast Guard's Foreign Gas Carrier Examiner Tactics, Techniques, and Procedures, or as we call it, the TTP, SIGTO's Liquefied Gas Handling Principles, the 4th edition, and the IGC code. If you don't have a copy of our TTP, you can download or print a copy for free from our website, www.uscg.mil/LGC NCOE. So let's get started. Now, any release of flammable or toxic gases poses an immediate threat to personnel and equipment in the vicinity of the gas vapors. Because of this, it's necessary to detect accidental discharges as early as possible to avoid the possibility of vapor cloud fires, explosions, or the accumulation of deadly toxic chemical gases. These detection requirements come from Chapter 13 in the IGC code. Now, before we get too far into the IGC requirements, let's first talk about explosive and toxicity limits. For today, we're going to use methane as an example. Now, methane has a flammable range of 5 to 15% by volume. This means that if a space being measured for gas concentration contains 5 to 15% methane, it could ignite if an ignition source is present. Now, any gas concentration less than 5% would be too lean to burn, and methane concentration over 15% would be too rich to burn. This makes 5% the lower explosive limit, or LEL, and 15% the upper explosive limit, or UEL. Now, since 5% gas concentration is the first point at which the flammable atmosphere is flammable, we call this 100% LEL, and this is where the IGC code bases its alarm requirements off of. Chapter 13 of the IGC code requires an audible and visual alarm to activate if gas concentration reaches 30% of the LEL. This does not mean that there is 30% of gas concentration within the space, but instead is 30% of the lower explosive limit, which in this case is 1.5% by volume, since methane's LEL is 5% by volume. This low safety margin is to allow the crew to receive the alarm and act accordingly before flammable conditions are present. Now that you have a solid understanding of LEL and by volume readings, let's move on to toxicity level of gases. Chapter 19 of the IGC code is a summary minimum requirements for all gases listed in the IGC code. For gas detection, it's important for Coast Guard examiners to look at the cargoes being carried and know the vapor detection requirements. We'll use butadiene for this example. In Chapter 19, the vapor detection requirement says F and T, which means flammable and toxic. So what does a fixed gas detection need to monitor flammable or toxic gas concentrations? As we discuss this further, keep in mind that Chapter 13.6.1 of the IGC code requires a fixed gas detection to be suitable for all cargoes being carried. Now, the flammable range of butadiene is 1.1 to 12.5% by volume, which makes 1.1% by volume the lower explosive limit. By IGC requirements, the gas detection is required to alarm at 30% of the LEL, which would be 0.33% by volume. So that's the flammability range. Now let's talk toxicity levels. Always remember when trying to determine parts per million levels in relation to percent by volume readings that every 1% by volume is equal to 10,000 parts per million. That being said, the immediate danger to life and health, or IDLH, of butadiene is 2,000 parts per million. Now, if a vessel was measuring the flammability range of butadiene and had their gas detection equipment alarming at 30% of the lower explosive limit as required by the IGC code, the gas concentration would actually be at 3,300 parts per million, which is well above the IDLH toxicity range of butadiene. Because of this difference in flammable and toxic vapor gas detection, it's important as Coast Guard examiners to know the gas is being carried and authorized on the ship you're examining, and to always ask for the safety data sheets for the cargoes carried to help you determine if the gas detection system is detecting the appropriate vapors and the appropriate vapor levels. Now, in summary, remember that fixed gas detection must be suitable for the cargoes authorized. Remember to go to Chapter 19 of the LGC code to help you determine what gas vapor concentration should be monitored. As we progress through the gas detection requirements and testing procedures, we'll dive deeper into the components of the gas detection system, the portable gas detection requirements, and how to properly calibrate and test and their procedures during a COC examination. Now, thanks for tuning in. See you soon.